Hello everyone, and welcome to this example recording on impedance. So the question we're going to be attempting reads the following. Determine Z in polar form when omega is given as 100 radians per second. So what we notice in the circuit first should be that we have resistors, we've got a capacitor and an inductor. So for us to determine the total impedance of the circuit, we need to get the impedance of the capacitor and the impedance of the inductor. So the impedance of the inductor first is given by J omega L, which is J omega we know is 100 multiplied by the inductance, which is 5 millihenries, and that's going to give us 100 multiplied by 5 times 10 to the negative 3, which is 0.5. So that's going to give us J 0.5 ohms. And the capacitor ZC is equals to minus J over omega C, which is minus J over 100 times the capacitor value, which is 1 millifarad. So that will be minus J over omega, which is 100, times the capacitance value, which is 1 millifarad times 10 to the negative 3. That gives you minus J 10 ohms. Right, now that we have that, we can effectively see the circuit as a combination of resistors, because we have all the values now in ohms, and the Z value we're looking for sits there. That's 2 ohms, negative J 10 ohms, J 0.5 ohms, and 10 ohms. Right, so first we look for series connections, then we look at parallel connections, and if we can't find any, then it will probably be Y delta transformations to be able to simplify the circuit. We should be able to see that the connection between the J 0.5 and the 10 is a series connection, and the combination of those with the minus J 10 is a parallel connection. So we can then say Z is equals to 10 plus J 0.5 in parallel with negative J 10, and once we have that parallel combination, it should be in series with the 2 ohms. Right, so 10 plus J 0.5 in parallel with minus J 10. 10 plus 0.5 I, that will be in parallel with minus 10 I, and that gives us a value of, let's get that in polar form, gives us a value of 7.25 at an angle of negative 43.6. And that is in series with the 2 ohms, which then gives you a final value of 7.25 angle negative 43.6 plus 2, which will sum to 7.25 minus J5. And if we get that in polar form, it'll give you a final answer of 8.81 angle negative 34.6. Right, and that's the final impedance for the question that has been asked. Thank you for watching this video and enjoy the course.